Let's start. Hello, everyone. Thank you very much for your time and presence. It is a privilege to have you all join today. We welcome everyone to this OPC UA for Embedded and Constrained Devices webinar. My name is Zishan. I take care of digital marketing here at Utthunga. In today's webinar, we will share the importance of OPC UA in embedded and low footprint devices to help you understand why do you even care for OPC UA in your embedded devices. We will then help you understand the various considerations and decisions that you will have to take to implement OPC UA in your embedded devices. Before we get started, I would like to take a couple of minutes to introduce Utthunga. Next slide, please. We are a product engineering and industrial solutions company. For over 13 years, we have partnered closely with industrial OEMs to build products and solutions from concept all the way through the life cycle of the product. Our engineers have added digital layers to mechanical, non-mechanical field devices, built configuration or calibration diagnostic software, highly sophisticated data integration, visualization and analytics solutions, provided consultation and services on industrial security and quality engineering. We offer services in application development, embedded services, IIoT, and verification and validation. Our services are targeted to OEMs and end industries in process, factory, and power domains. Next slide, please. These are the few industry consortiums we closely work on: connectivity and protocols. Field asset connectivity is a foundation for Industry 4.0. That's how we started as a company about 13 years ago. That is connecting field devices, our assets, to the hardware and software systems up in the value chain. Our association with these consortiums, and most importantly, the OPC Foundation, is rooted in our commitment to help our customers build interoperable industrial systems. Next slide. With that, I would like to introduce the speaker for today. Chatrapathi is Director Embedded at Utthunga and an OPC expert. He is an active member in OPC Foundation Working Group and has contributed in creating use cases for OPC PubSub on small footprint devices. Chatrapathi has solid understanding of OPC UA on devices companion specification. He has executed several projects with OPC Nano Profile, servers with high performance demands, servers with heterogeneous communication requirements for protocols like HART IP Gateway, Ethernet IP, IC 61850, BACnet, etc. He has good knowledge on field devices, NAMO standards, and semantic ID. Also, he has worked with different open source and commercially available OPC UA stacks. Just a few quick points before we start the session. The duration of the webinar is 60 minutes. We will utilize the last 10 minutes for Q&A segment. Please send in your question using the Q&A icon on the left-hand side of your screen. The presentation slides and the link of the webinar recording will be emailed to you post the webinar. We request you to click on the full screen icon on the left-hand side of your screen to get the good view of the slides. Before I hand it over to Chatrapathi, a quick poll question for 30 seconds. Request the attendees to please give your answers. What describes your requirement with respect to embedded OPC UA? So the options were product development, stack porting, and application development, testing, certification, end user. So most of the attendees have selected product development. Thank you for your answers. So without further ado, I would like to hand it over to Chatrapathi.
Welcome everyone. I'm Chatrapathi. I lead today's webinar with respect to having OPC UA on embedded and constraint devices. So before we get into the actual agenda on how do we achieve having OPC UA and the embedded devices, let's look at why there is a need for OPC UA on embedded devices. So this is a standard hierarchical based architecture which most of us who work in industrial automation are aware of. So with this architecture, there are some limitations because of the way the data flows from bottom to up in a very hierarchical and filtered manner. So the landscape of businesses are changing due to different aspects, mass customization, increasing velocity of innovations and obsolete maintenance, and there's a stress on engineering teams and as well as end customers to provide a quick response, and new and innovative threats are emerging each and every day. So maintaining a security aspects, and then pressure on increasing productivity and as well as optimizing cost, and of course the different types of regulatory compliances that needs to be followed. So to meet these demands, there is a need for data that is being produced at each and level to be accessed by other levels as well without much of the filtration. So in a way, the demand for data from each and every level to be accessed in all other levels, so well-informed decisions can be made. The kind of hybrid or flat architectures are emerging. So even though in the physical world, the connectivity and how the systems are connected and everything looks still as per the hierarchical architecture, with respect to data availability and data accessibility, it is going towards a little more flat and hybrid architecture. So for this to work, there has to be a unified communication mechanism from bottom layer to the topmost layer, and as we already aware, there are several different reference architectures like REMI and others have been recommending OPC UA as the communication protocol for having this data across all the different layers in a flat way. So now to have OPC in each and every layer, at the upper layers, majority of the cases, the OPC is available as an application on a PC based or above. But at least in the control systems layer and as well as sensors and devices, that's where the real challenge of enabling OPC UA comes with its own constraints with respect to resources, with respect to design constraints, with respect to cost, and so on. So we'll try to address. So if you are trying to start a device, or if you are looking to enable OPC UA on any of your existing devices, we hope that this webinar presentation will give you a simple handbook kind of way, or quick start kind of way, so that you are better equipped to make any decisions with respect to that. Now again, this is just to give an emphasis on why OPC. So if you can see, there are OPC UA with all these different organizations jointly working together to create different information models and companion specifications to work with and to promote interoperability with OPC UA. So when you are working on devices, most of the devices fall into either IO level or some of therein which have IC 61850 and BACnet on the building automation side. So like that, different protocols and different levels of integration would be required. So with respect to that, there are different companion specifications. So when your device out of box supports OPC and that protocol specific companion specification related information model, then that becomes really value addition for the end customer in terms of device replacement, in terms of maintenance, in terms of not getting locked into a single vendor, and of course it solves the problem of making the data available from top to bottom at all layers. So having an OPC on your device, it brings different advantages. So it becomes plug and play. So tag creation and configurations are not required anymore because the address space is already there on the device, and you are just selecting the tags and creating subscriptions so that you can have the data available. It reduces different IT and training and infrastructure needs, because most of the cases in the existing infrastructures, there are these PCs installed to gather data from different nodes where OPC UA servers with corresponding low-level protocol drivers are running to gather the data. So the need for such PCs sitting in between reduces, and then thus reducing the IT costs and the training costs involved in configurations and other aspects of maintaining the plant. And rapidly increasing standardization of different information models, it takes the plug and play to a different level. So even without supporting the information model, if you have OPC UA with your own vendor specific information model, still that will bring still some challenges with respect to device replacement. So those kind of challenges also can be eliminated when information models as per companion specifications are followed. And it becomes very easy to have a vertical integration or a cross-functional horizontal integration, like between the process that is happening in the plant versus the building's HVAC systems. So whereas that runs on backnet and then the process automation runs on a completely different network, but OPC UA companion specifications are there for all the different systems. So when you have a centralized place where you can have access to both the systems and write some integrated cross-functional applications based on how building's HVAC system is working, you may have to make some adjustments to the process and so on. Horizontal integration, like machine to machine or PLC to PLC communications, also becomes very easy and straightforward. And data accessibility, now that the data is accessible throughout the levels from device to the IT level directly. And most importantly, without OPC UA, whatever the values that we read from the specific devices, their values. So you need to look elsewhere to get the meaning out of the value. But whereas OPC tags are very much integrated with the different attributes, so it is not just data; it is information, and with some logic added on top of the information, it becomes an actionable information using which you can take some actions which would yield the results. And of course, security. So OPC by design, by specification, security is inbuilt in OPC. So again, overall, if we look at it, configuration and configuration training costs, configuration efforts are reduced. PCs and IT support cost is reduced. Customer support cost is reduced because again, it is a simple, straightforward thing. Customers doesn't need to worry about different types of configuration files, different types of things that they need to be aware of, and then there's no need to provide different protocol converters or drivers or some customized softwares to handle these heterogeneous devices. So this is just one simple use case again to see the advantages of having an embedded on OPC. So here we have a network monitoring system which connects to a Profinet network, where it is continuously monitoring the Profinet network, and it has some algorithms in it where it can determine how the network traffic is behaving. Based on that, it can raise some alarms and warnings. So when the rest of the entire system is connected, and OPC UA can connect to the Profinet and expose the data, this specific network monitoring system doesn't have any OPC within it. Then whatever the alarms and warnings that are being exposed need to be manually addressed by looking at some web application which runs on the monitor, and then addressing those alarms and so on. So by enabling OPC UA in it, whatever the addressing of the alarms, and based on the alarms, taking some either automated actions or even manual actions, prompting for manual actions, all this becomes very easy because of the data is suddenly now available on OPC. So at a high level, this is the agenda for today. Requirements definition. So this is again the agenda is oriented towards if you are trying to develop a new device, or if you already have a product or device in which you want to enable OPC UA, how the flow should be, and what are the things that you should consider, what is the approach. So this gives some starting pointers with that respect. So with respect to requirement definition, so if you're coming out with either new product or even enabling existing one, so we need to look at these different aspects. So what kind of application the product is going to be? Is it going to be a field device, or is it going to be a gateway device, or aggregator device, or a data logger device? So what kind of application that's going to be? And with respect to functionality, how do we do the configuration? How can you make the device discoverable in the network, and so on? You can define which way that needs to be done. And again, the performance requirements based on the application, the requirements related to number of tags, and then the update rates for that specific number of tags, and different number of connections that it should support at a given point of time, and different subscriptions, and in each subscription how many sets of monitored items should be supported. So these are all becomes your performance requirements. So subscription is nothing but a collection of monitored items. Monitored items are basically tags. So in a subscription, you will define that for all these monitored items, I need to have an update rate of 1 second or 500 milliseconds and so on. So these requirements needs to be defined as a first step based on the application type, functionality requirements, and performance requirements. In addition to that, you need to come up with hardware requirements with respect to form factor, how it is going to sit, where it is going to be there, and any indicators, any buttons on the box. So with respect to that, and also what kind of hardware configuration you are going to have based on. Again, the hardware configuration is somewhat linked to the performance requirements and functional requirements. And application as well. And then what kind of security requirements for your device you want to have. So with respect to authentication, authorization, who should have access to it, whoever based on some roles, who should be able to do what. So such kind of definitions need to be drawn out, and of course because the OPC UA security aspects use certificates for most of its security needs. So you should have a definition of how do the certificate management is handled by your device and the configuration software of the device and the overall system. And so different hardware specific certifications, and as well as whether you need to get your device certified by the OPC Foundation test lab. With respect to that also, you need to have some requirements defined. So OPC Foundation also allows certified devices to be displayed on their website by the vendors, and of course non-certified devices are also displayed, but they are displayed in a completely different category. So under certified category, most of you can see the certified devices. So at a very high level, at a broad classification, if you look at it, there are servers, clients and servers. So any of the application, if you look at it, for example, if you look at an aggregator, so either it can be a client or it can be client and server. If you look at a data logger, it will be a client. So that way, any of the application layers will fall into one of these three categories at a high level. So server examples are where simple sensor device exposing one or two variables and their engineering units. Starting from there, it can go up to where a server which aggregates data from several field devices and exposes the data from all these field devices via OPC UA. So PLC is one example of server where it can expose few thousand parameters based on all the underlying devices with which it is connected to. At a high level, you can imagine the architecture to be something similar to this, where the PLC's memory block will be there, and it interfaces with address space. The variables in the tag values in the address space are mapped to blocks of memory here, and any OPC UA client connects and browses this address space, creates subscriptions, will have access to the values that are being gathered from these underlying devices. Client examples are like data loggers or a simple IoT clients where OPC UA client connects to a server, gathers the data and publishes the data to the cloud over MQTT or AMQP, or even using OPC UA PubSub publisher as well. So there are different client and server examples. So aggregated server is one such example. So this aggregated server actually connects to different OPC UA servers and exposes the collective address space as its own address space. So any client that connects to this specific aggregated server will have access to all the underlying servers that are connected to this. So in a way, it works like a OPC UA gateway where the underlying devices are also OPC UA servers. So these are broad classification of devices. Then we'll go into development approach. So there are three approaches at a very high level. So you can think of full product development and maintenance, including hardware, stack, application, and so on. The second option is to take support of different technology providers that are there in the market based on your in-house capabilities and how your teams are composed of, and how enabled they are on the OPC UA related technologies. And the third option is to just give out a very high level requirements to a technology provider where they can design, develop, and deliver full product for you. So what technology providers can provide you with respect to this? So they can support in defining the requirements. They can evaluate if your existing device it is feasible to enable OPC UA on your existing device. Different hardware designs, prototyping, and supporting in getting different hardware related certifications, or the entire hardware itself they can provide you as a CARTS product. Or in some cases there are different MCUs that comes with OPC UA stacks ported to those MCUs, and stack implementation, stack development, or different protocol selection, profile selection, or if you want to evaluate different stacks that are available in the market, then they can do the evaluation and give the report. And coming up with your own vendor specific information modeling, or supporting any of the existing companion specification based information modeling. Different configuration applications of based on OPC UA client based configuration applications which run on PC to configure your OPC UA specific devices. Pre-compliance testing and also certification testing on the OPC Foundation test lab. So in these all areas, different technology providers have different solutions available for you. We'll look at hardware considerations. This is again, there are some vendors who have ARM-based processors and Intel-based processors for which they have already ported one of the commercially available stacks, and you can get that as a package. So that will be a very starting point where you can design your hardware and device design around that specific MCU or MPU. So when you are picking such solution, you need to consider different aspects. So usually in such cases, the stack license still lies with the stack vendor. So you will have to get an additional license for your product line. But most of the hard work of porting to that specific controller and making it very configurable and usable is already done. You just have to get an additional product license for your this thing. And then what are the profiles that the stack supports, whether does it allow you to flexibly choose and switch between different profiles or not, what additional features does they have, do they have what are the kind of processor and memory requirements of that specific bundled stack with the controller, and whether so in some cases where you may most of the cases you may still want to retain the field bus level protocol as well to coexist along with OPC, where in some cases OPC is used only for the configuration purposes. Still the lower level cyclic data is still going on the field bus protocol. So for such cases, whether such multi-protocol support is there or not. So and based on the cost of this component, what will be your final development cost? So from these aspects you need to check and consider. And there are some designed boards, small boards, which comes as an integrated embedded board, and you will have to design your hardware design in and around that board, and based on that you need to complete your overall product design. In this, in addition to all the constraints and all the considerations that you need to make in the first option, in addition to that, you need to see how having this additional board is going to affect your overall hardware design. Is it compatible with your design. So from all those aspects, of course, these two options does not work well with any of the to enable OPC on existing products. These are for new products, and there are some in addition to the stack and the MCUs, there are additional industrial Ethernet based embedded switches are available from different vendors, where these switches comes with TSN support and also protocol specific firmware for that switch based on what kind of data they're publishing. So you can see how having such switch would accelerate your overall product development and will yield better performance with respect to the network communications. So there are industrial computers which has different multiple protocol supports, and with this, of course, this option is mostly will work for gateways and above kind of devices, where you are only focusing on your application development and just port the stack and then go ahead with the rest of the aspects. For the low level field level devices, this option doesn't work. So again, based on the kind of application, the kind of device that you are developing, these different options are available, and different aspects of hardware considerations you need to do based on what you're. We'll look at software considerations. So major components of any embedded OPC implementation is this. So OS, so whether it is going to be OS and then information model, stack, application, and as well as device application. So operating systems, there are different considerations: FreeRTOS, TIRTOS, RT Linux, VxWorks, and of course pure embedded solution with no OS also can be considered. So performance and memory requirements of the OS need to be looked at. Excuse me. Based on your hardware configuration, whether this is going to match. Do you have enough room for your application development, and as well as stacked porting and so on. So with respect to that, you need to look at the memory requirements of the operating system. So you need to, there will be some effort on porting the stack, porting the specific OS to your target, development, debugging, and maintenance efforts. With respect to information model, you can choose any of the existing information models. So there are several different information models are already available from the foundation and from VDMA and other organizations. So starting from a scale, or if you are looking for any of the industrial protocols, so for Profinet, for IOLink, for IEC 61850, for BACnet. So for many of the protocols, there are companion specifications. So you can choose any one of those, and then based on that, you can customize the information model to add your vendor specific features, so which your customers may look at it as a value addition rather than going with any other vendors. So you can still protect your unique selling points while following any of the company specification. As a different option, you can come up with your own information model. It requires information modeling skills. So again, you need to see if your in-house staff is equipped to create information models. The most important part of this is stack. So with respect to stack, again, you can think of developing your own stack where you'll have control over a total implementation of how it gets implemented and what kind of quality processes it goes through and so on, in terms of robustness, design quality, in terms of performance, optimizations and so on. So very high development and testing efforts need to be one, and also requires expert skills with respect to embedded development as well as OPC UA specification as well. You can buy a stack from technology providers where you will get a proven, tested, and the stack might have been already ported to different platforms, and you will get technical support with respect to stack porting and stack utilization, documentation, and so on. It requires some skills with respect to how you can develop an OPC UA based application. Updates and bug fixes, other maintenance you'll get from technology provider based on the kind of arrangement you'll have with them. There are some open source stacks. The most prominent one, as per my understanding, is OPN62541. And many of the industry companies are also invested in the stack and contributing towards that stack. Very recently, even PubSub TSN based features are also added to that stack. And apart from that, from the OPC Foundation also there is an NCC stack, but it's a very basic stack. Many features are not there. So again, with this, you have to spend some effort on porting to hardware, and you need skilled engineers to do the porting and handling, and inconsistent support and maintenance, because again it depends on how actively that specific community is managing the stack. So at least with respect to OPN62541, it is somewhat active. So different considerations, whatever the stack you may choose. So whether it is matching your defined functional requirements, the features of the stack, does they match? And whether the stack can handle the kind of performance requirements you have, and CPU and memory usage constraints, what kind of constraints the stack brings in. Different performance benchmark results you should look at with respect to specific target hardware in terms of tags and update rates and so on. So if you need to develop a simple application on top of it, how easy it is in terms of lines of code, in terms of documentation availability, in terms of other resources, how easily you can integrate the stack and OPC application with your device functionality. So suppose if you are having a measurement device, you have your own device functionality which takes care of the entire measurement and doing all the calculations and so on. So how this OPC application integrates to that, and you should be able to either leave out the features or add the features specifically as per your requirement. So that kind of flexibility, is it given at code compilation level or is it given at runtime? So from that perspective, you need to look at how well it is documented, and different reference applications, whether the stack vendor is providing or not. So based on all these aspects, you can choose a stack. So let's look at profile selections. So this is with respect to, so once you have all these requirements defined and everything is figured out, stack has been selected and all that. Now, based on the kind of performance and based on the features, based on what you are actually doing, with respect to that, you need to consider the following to select the profile. So for servers, there are this nano embedded device, micro embedded device, and then embedded device and standard. These 4 different profiles are there. And in addition to that, there are other profile categories are there: client, publisher, subscriber, GDS, transport, and security profiles, and so on. So those are more like a feature. So which one you are trying to add to? So with respect to nano, that is the most smallest and bare minimum kind of profile. So in addition to core server facet, there are few other things to support. Suitable for very small devices, key requirements are at least a single session should be there, and then server object capabilities object should be there, where the maximum packet sizes and number of connections and other things are published by the server. Authentication with username and password became a requirement recently, and basic read and write services should be there. Micro embedded is a little more than nano, so this is most important addition from nano to micro embedded is number of sessions, and of course the subscription comes into picture, whereas in nano there is no subscription. So here subscriptions and monitored items are added. And then the next profile is embedded device. The main addition from micro to embedded device is security. And of course there is a ramp up in number of subscriptions, number of connections, sessions, number of tags that's supposed to be there. And in addition to that, method calls are also added in embedded device profile. The standard device profile, all the features that are there in all the three profiles, plus high requirements with respect to number of sessions and number of subscriptions and additional diagnostic information and so on is added. So if you see that any of these standard profiles are not meeting your requirement, you can pick and choose different specific facets at a conformance unit level from the existing feature set of OPC UA, and you can come up with your own list of such facets. Still, you will be able to get your device certified for the OPC UA compliance. So, example customizations: nano plus transport security, or nano plus security policy, or micro plus diagnostic information. This way, different customizations can be done, or it doesn't have to be bound to any base profile also. So with respect to security, so there are different security goals defined with respect to OPC security. So authentication, authorization, integrity, confidentiality, communication security, and with respect to availability, how it is going to protect itself so that it is available most of the times, and reliability, auditability based on what are all the events that are happening, who accessed what, when, and what has happened in all such cases, boot up security and firmware security. So for each of these security goals, there are specific security threats that are there. So we'll see how OPC UA handles these specific security goals. So authentication related, it handles by providing username, password, and X509 certificate based Java Web, JSON Web Token, etc. Authorization related, it provides mechanism to exchange credentials. So based on that role, how much or what level of your information model you are exposing, or you are allowing them to view or edit or read. So that is application and implementation specific. Integrity is provided by the secure channel mechanisms that are part of the OPC UA communications. Symmetric and asymmetric signatures are used so that the integrity is maintained. So the end-to-end encryption is there on the OPC UA based on the specific security policy that you are going to select for your device. Communication security, this is again end-to-end encryption with end-to-end encryption of the data, and the communication, whatever is happening, is encrypted. So availability with respect to this by design itself, and also in the OPC UA security specification, there are several recommendations. So by following that, your OPC UA system can be made more available. Auditability. So there are different auditability and audit related, audit trials related services are there in the OPC UA specification, which make sure that each and every event that has occurred is logged or reported. So with respect to your device, when you are implementing OPC UA related aspects, either embed TLS or OpenSSL or any other equivalent crypto library, you may have to port to the platform. So if so that this activity would be usually part of porting the OPC UA stack. So usually the OPC UA stacks provide an additional porting layer where you can interface with one of the available crypto libraries. So you need to take care of that. And of course, the moment you want to bring security into picture, the CPU and runtime memory utilizations, everything goes high. So based on that, you need to consider at the beginning itself to have a better hardware configuration. So yeah, and then certificate handling related, you need to create some workflow on how certificates are exchanged with your device, how a certificate is moved to a trusted store, and how it is moved out of trusted store. Are you going to have a self-signed certificate generated on the device if an existing certificate expires? So all such workflow related considerations you need to do, and based on that corresponding implementations you need to take care. In addition to OPC UA security, as an embedded device, you need to have some additional device security mechanisms in place. So you need to have secure boot, which is based on code signing and image verification, so that someone else cannot just come in and flash the device with their own firmware. So whatever the data that is being stored on the device, it needs to be stored in an encrypted manner. For example, some configuration files or some username and password sets where you will be checking against when somebody try to log in. And prefer to have certificate based authentication instead of username and password. Implementing a simple IP and port list based filtering makes it easy for you to prevent any communication from different IP addresses that are not as part of the list. So this filtering can be part of TCP IP stack that you are going to port to the target platform. So from some of the technology providers, there are such TCP IP stacks specifically for embedded devices with such very simple role-based packet filtering and protocol filtering implementations. Creating and keeping log of all the failed attempts with respect to different wrong passwords entered, expired certificates provided for to gain access, how many connections were rejected by the certificate validation or by the IP and port based filtering mechanisms, and so on, so that you can identify if a specific device is being attacked or is being targeted more than any other devices. So rising status flag based on if number of attempts are going beyond certain number, maybe you can raise an alarm as part of your device implementation. So all and different configuration options to disable. So for example, if you have a device with 2 Ethernet ports, and if it is not actually connected in the ring network, you should have an option to disable the port through the software switch, so that anyone who just plugs into the open port will not gain access to the network. So such feature to enable or disable any additional interfaces of the device should be taken care. So these are all to have a more secure device. beyond the security that OPC provides. So with that, I have reached end of my presentation. Originally, this was we wanted to do it as a part of series of presentations. Once we moved away from that idea, I had to squeeze little more details in with respect to basic OPC and also with respect to security. And now we can look at different questions that are there, and whatever the questions I'll be able to answer now, I'll be able to answer now. Anything if we miss, we will send the email reply to the unanswered questions.
I request the attendees to please drop in the questions in your Q&A box.
So there's one question: does Utthunga recommend to replace OPC DA with OPC UA for their client as well as their server? Okay. So most of the legacy installations still have OPC DA already installed at the field level, but the DA comes with its own challenges with respect to decom settings, and every time there is a Windows update, all the decom settings will go to havoc, and again you need to start fresh. And so from at least from Utthunga, we have a OPC DA to UA converter, which you can use and configure once on the DA to UA converter. Suddenly, all of your DA installations becomes UA. Now, the customers are very much reluctant to completely replace DA with UA. As long as you are providing any ad hoc or different solution where it can be converted and made available via UA, that goes well with the customers. So it depends on the situation. So if you're trying to create something new, then you might as well stick with OPC UA. But if there is a legacy installation, and as long as the customer says that if it is working, I don't need to change it, in that case you can use the converters.
Chatrapathi sir, one more question. We are actually in a tight schedule. One last question.
If you have OPC client and we require OPC server, should we go with OPC server or UPC server, for example? Yeah, so our UOPC server is capable of gathering data from different OPC DA servers as well, because it internally has a DA client. But if you have a DA client and trying to expose the data, whatever is connected to DA client, so that is what I am referring to as OPC DA to UA converter. So we have both. What's the smallest footprint of OPC stack for embedded devices? Okay, so this is again, there's no straight answer for this. Different vendors have claimed different numbers. So some vendors have claimed 30 KB runtime memory. Some vendors have claimed some 50 KB and so on. So there is no fixed answer for that. Yes, Jishan, any unanswered questions will. So on embedded devices, can we integrate the web protocols like MQTT? Yes, again, it depends on the use case, what kind of device you are producing. So if you are creating a simple IoT connected device, then yes. Or even if you are creating a gateway where OPC UA is used to gather all the data, and for publishing to the cloud, you can use MQTT. So such gateway devices also can be enabled with them.
Okay. So thank you so much for your questions and participation. There are few questions that we were not able to answer today due to the time constraint. We shall answer the remaining questions via email soon. Before we move on, let's have a quick poll for 30 seconds. Request our attendees to please drop in your answers. So the question was, what is your level of in-house competency on embedded OPC UA? So majority of our audience have opted for not self-sufficient. So thank you for your replies. Next slide, please. We would like to support you to evaluate and implement the right OPC fit to your products and solution. Please reach out to us at contact@utthunga.com. I repeat, contact@utthunga.com. Thank you everyone for participating in this webinar. We hope it added to your existing knowledge base on OPC UA for embedded devices. I will quickly share an update on our previous and upcoming webinars. We recently concluded a webinar series, a sequence of 6 webinars on various aspects of OPC. You can view these webinars on our YouTube channel. Search for Utthunga in the YouTube search bar. You'll find us. Navigate to the OPC UA Inside Out playlist to access the recordings. We are covering a very relevant topic, security in OPC UA, in our upcoming webinar on September 10th, 2 weeks from today. Please block your calendars. We will share the registration links shortly. If you want us to cover a specific topic, please do email us at contact@utthunga.com. Hope to see you all on September 10th. Finally, do follow us on LinkedIn. We share all the latest information and our ongoing activities there. Stay safe. Thank you.
Thank you very much for all of your time and presence. Thank you.